Welcome to The Explainer. So today we're diving into August 18th. Now, I know it might sound like just another day on the calendar, but it is arguably one of the absolute greatest dates in the entire history of mathematics. And I'm going to show you exactly why.
Because on this one almost magical date, across completely different centuries and entirely different countries, some incredibly brilliant minds solved massive mysteries. Mysteries that literally built the modern world you and I live in right now.
Let's actually meet them one by one. It's wild to think about, but this single day connects geniuses from the 1600s all the way through to the 1960s. And together, they laid the absolute foundation for the exact technology we rely on every single day.
So let's start here. Have you ever wondered why your Spotify music sounds so crystal clear, even when you're stuck on a really slow internet connection? Seriously, think about it for a second. How does a massive, complex audio file just travel through the air to your phone so perfectly and instantly?
Well, the answer actually takes us all the way back to August 18th, 1685, with the birth of a remarkably brilliant thinker named Brook Taylor. Now, Taylor spent his time studying the mechanics of vibrating strings. And through that work, he proved that these huge, messy, complex sound waves can actually be sliced up into really simple, manageable mathematical frequencies. It's like breaking down a giant puzzle. And that brilliant breakthrough is exactly why our phones today can compress heavy audio files and just stream them flawlessly over the air.
It honestly leaves us with this incredible realization. Every single song you have ever heard is, secretly, entirely made of math.
Okay, so we're still on August 18th, right? But now we're jumping way forward to 1832. Same date, totally different country, and honestly, an even bigger idea. Let's keep going.
Here's our second mystery for you. Why does your phone's GPS always seem to find the fastest route? Even when you're in a massive city with hundreds or thousands of overlapping roads, it just knows. To really understand how that works, we have to look exactly 147 years after Brook Taylor, to August 18th, 1832. And that is the birth of Eugène Rouché.
You see, your navigation apps, they don't just guess. They rely on Rouché's theorem. Rouché discovered this incredibly elegant way to solve massive, overlapping systems of linear equations basically instantly. So his algebra acts like this super-fast filter. It aggressively eliminates all the bad paths, pinpointing the single best route for you in literal milliseconds.
So it turns out the absolute fastest path to anywhere isn't drawn by a map. It's drawn by equations.
One single date, so many stories. Let's leap right into the 20th century now, where, you guessed it, August 18th strikes yet again. Think about your daily scrolling habits. How in the world do social media and shopping apps predict exactly what you want to see next? I mean, sometimes it feels like they're literally reading your mind, right?
Well, that modern magic is entirely thanks to Carlo Bonferroni. He was a brilliant mathematician whose life actually came to an end on our fateful date, August 18th, 1960.
What Bonferroni did was create what we call probability inequalities. You can kind of think of them as mathematical noise-canceling headphones. They allow computer systems to look at millions of overlapping events, exactly what you click, what you watch, what you buy, and then filter out all the random noise. That's how they seamlessly predict what you're going to want to see next.
It proves a really fascinating truth about all those algorithms ruling our feeds. Predicting the future? It's really just counting the right possibilities.
Okay, we have one last incredible mind to meet today. We're going to jump just slightly back in time for this one to another absolute genius who was born on this exact day in 1941. And here is our final wonder for the explainer. How does a Wi-Fi signal travel perfectly to your laptop or phone, straight through a crowded room that is just packed with invisible, bouncing, totally chaotic waves? Enter Domokos Szász, the final architect of our digital lives we're talking about today, born on August 18th, 1941.
Szász actually mapped out the ergodic theory of bouncing objects. Specifically, he proved something called the Boltzmann-Sinai hypothesis. Basically, in simpler terms, he spent his entire life studying systems of hard objects bouncing off each other, kind of like billions of chaotic billiard balls crashing around. And he proved that what looks like pure random chaos actually follows strict, highly predictable mathematical rules. That breakthrough gives our devices the exact physics they need to pluck a perfect Wi-Fi signal right out of thin air. Which leaves us with this genuinely beautiful thought. What looks like pure chaos is, in reality, just following a perfect hidden rule.
So let's bring this all together. 1685, 1832, 1941, 1960. All of these truly extraordinary minds, forever connected by this one date, August 18th.
Because every single person we met today, despite living in totally different centuries in different countries, they all essentially asked the exact same question. What is the pattern hiding inside the chaos? And because they asked that question, our modern world has GPS, seamless music streaming, predictive algorithms, and lightning-fast wireless internet.
So, I'm going to leave you with this one last thought. As you look around at all the technology powering your daily life, what hidden pattern in your world is just waiting to be discovered today? Thank you so much for joining me for this explainer. Keep wondering, keep exploring, and I'll catch you next time.